Managing data is very important because data must be high quality to be useful. High quality data is accurate, complete, timely, consistent, accessible, relevant, and concise. Information is only valuable when it is relevant, meaning it is useful and appropriate for the task or decision being made. However, data is difficult to manage for several reasons. First, the amount of data grows very fast over time. Organizations must store historical data for long periods while also handling new data continuously. Second, data is often scattered across different systems and locations, such as multiple servers or departments, and collected by many people using different tools. Data also comes from many sources, including internal databases, personal input, and external sources like commercial databases or the internet. New data sources, especially from the web, are often unstructured, making them harder to organize and analyze. Over time, data can become outdated or lose value, which is known as data decay. Finally, data security, quality, and integrity are critical but can be easily threatened if data is not managed properly. Traditional file processing is an older way of managing data in organizations. In this approach, different departments develop their own business applications independently, often without an overall company-wide plan. Each application uses its own data files, which contain only specific types of records related to that department. For example, the student system, library system, and accounting system each maintain their own separate files. Because of this, data is stored, organized, and processed separately for each application and often runs on its own computer system over time. This leads to multiple master files being created and maintained by different departments. This makes the system difficult to manage and maintain as data can be duplicated, inconsistent, and hard to update across the organization. Traditional file processing has several important limitations that make it less suitable for modern organizations. One major problem is program data dependence. Each program is closely linked to its data files, so any change in the data format requires changes to the program. Another issue is data redundancy. The same data is often stored in multiple files across different departments, which wastes storage space and creates duplication. This leads to a lack of data integrity because duplicated data may not be updated consistently and can become inaccurate or conflicting. Traditional file processing also has limited flexibility. It is difficult to retrieve data in new ways or generate new types of reports without writing new programs. Security is weaker because data is spread across many separate files, making it harder to control access and protect sensitive information. Finally, there is a lack of data sharing and availability. Departments store data separately, so sharing information across the organization is slow and difficult. A database is a collection of related data that is stored together so it can be easily accessed, managed, and updated. The data in a database can be stored in one central location or spread across multiple locations, which is known as a distributed database. A database may contain just one file, but more commonly it consists of a group of related files. Inside the database, data is organized clearly. A file is a collection of related records, and each record is made up of related fields. For example, a student record may include fields such as student ID, name, and course. To manage a database efficiently, a database management system or DBMS is used. The DBMS is software that allows users and applications to store, retrieve, update, and control data easily. Using a database provides many advantages compared to traditional file processing. One key advantage is reduced data redundancy. Data is stored in one central place, which reduces duplication and saves storage space. Databases also improve data integrity. Because there is a single shared version of the data, information is more accurate and consistent across the organization. Another benefit is shared data. Multiple users and departments can access the same data at the same time, which improves collaboration and coordination. Databases allow easier access to data. Users can quickly search, retrieve, and update information using simple queries. Finally, databases help reduce development time. Developers do not need to create separate data files for every application because data is already organized and managed by the database system. Although databases have many benefits, they also come with some disadvantages. First, a database system can be more complex than traditional file processing. It requires careful design, setup, and management. Databases are also large in size because a database management system or DBMS is powerful and complex. It needs more storage space than simple file systems. Another issue is that databases usually require special training. Skilled professionals are needed to design, develop, and manage databases and related applications. Databases also need more memory and processing power, which can increase hardware and operational costs data in a database. May be more vulnerable because a large amount of data is stored in one central system. If security is weak, many users can be affected at once. Finally, if a database system fails, is damaged, or is destroyed, users may not be able to perform their work until the problem is fixed. A database management system, or DBMS, is software used to create, process, manage, and control a database. It is important to understand that a database and a DBMS are not the same thing. A database is the collection of data, such as tables, relationships, and metadata. A DBMS is the software that allows users and applications to work with that data. Common examples of DBMS software include Microsoft Access, Oracle SQL, and MySQL. A database application includes items such as forms, queries, and reports. These applications act as a bridge between users and the database. The DBMS sits between the application and the actual data files. When an application requests data, the DBMS locates the data in the database and returns it to the application. By managing data centrally, a DBMS helps reduce data redundancy and inconsistency, making data more accurate, organized, and reliable. A data warehouse is a collection of data that is mainly used to support decision-making and to generate business intelligence. It brings together data from many different operational databases and standardizes the data so it can be used consistently across the whole organization. Because the data is consolidated into one place, managers and users can analyze information across the entire organization. Rather than looking at separate systems, one major benefit is that users can access data quickly and easily, often through web-based tools. A data warehouse also allows users to perform more advanced and detailed analysis that may not be possible with everyday operational systems. It provides a single consolidated view of organizational data, which helps users see the big picture. Overall, data warehousing helps improve business knowledge, supports better decision making, provides competitive advantage, improves customer service and satisfaction, and helps streamline business processes. A data mart is a smaller and simpler version of a data warehouse. It is designed to support the needs of a single department or business function such as marketing, finance, or human resources. Because data marts store less data, they are less costly to build and maintain compared to full data warehouses. They can also be implemented more quickly, allowing departments to access useful data without waiting for a large enterprise system. Data marts are more focused in scope, which means they contain less information, but the response time is faster when users query the data. Thus, a data mart is a department-focused, faster, and cheaper solution, while a data warehouse is larger, more expensive, and organization-wide. Data mining is the process of searching large amounts of data to find useful business information. It involves accessing and analyzing data that is usually stored in a data warehouse or a data mart. Data mining mainly performs two important tasks. The first is predicting trends and behaviors, such as forecasting future sales or identifying customer buying patterns. The second is discovering patterns that were not known before, such as unusual relationships or hidden connections in data. The real power of data mining lies in its ability to analyze data quickly and intelligently, helping users answer business questions and make better decisions faster. Big data refers to data sets that are so large or so complex that traditional data processing methods are no longer sufficient to handle them effectively. Big data is commonly explained using four key dimensions. Often called the four V's, The first is volume, which refers to the huge amount of data collected from many different sources, such as social media, sensors, and transactions. The second is velocity, which describes the speed at which data is generated and processed. In many cases, data is produced continuously and needs to be handled very quickly. The third is variety, meaning data comes in many different types and formats, such as text, images, videos, and sensor data. The fourth is veracity, which refers to the uncertainty and quality issues in data, such as errors, noise, and bias. Big data also creates several challenges. Large amounts of data must be managed properly. High-speed systems are needed to process data quickly. Ensuring data quality is difficult, and tools like data visualization can help users understand and trust the data. A cloud database is a database that runs on a cloud computing platform and stores data over the internet instead of on local servers. Because cloud computing needs a place to store data. Cloud databases are used as web-based databases that can be accessed online. These databases are usually hosted by third-party service providers on remote servers, such as Amazon or Google, and users access them through an internet connection. Cloud databases run on the cloud provider's platform, which means data can only be stored and accessed when there is internet access. There are several advantages to using cloud databases. Data is easy to access from anywhere. They are easy to install and scale, meaning storage and performance can grow as needed. Security is often improved because cloud providers use advanced protection measures. Deployment is faster compared to setting up traditional databases. They are location independent and device independent, allowing access from different places and devices.